Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class, and today we want to look at wave 1. By the end of this lesson, you should be able to define wave, classify waves, and explain the types of wave and state and explain the properties of wave. Now, what I want you to know in this lesson is that we titled it Wave 1 because there are other waves that will be coming. We'll be having Wave 2 and trying to exhaust the lesson. However, this lesson is going to be more of the theory you need to know about wave. Now, if you look at the screen very well, you see that there are two kinds of waves. One is moving up and down. The one on the black, the one at the top is moving up, down, and as it's doing that, the wave is moving in this direction. So it is called mechanical wave. We also have another kind of wave, which is moving in two-dimensional, or should I say three-dimensional, because you see this one moving sideways and the other one moving up and down. And I'm going to say that they are orthogonal. That means they have a kind of angle between them. Now, when we talk about wave is talking about a transfer of energy from one form to the other. So we have different kinds of wave which we are going to look at in this lesson. And I want you to get ready, prepare yourself, and be happy as I take you through this lesson. Now, let's go to the first one and talk about the definition of wave. He said that a wave motion is a process of transferring energy or a disturbance in a form of kinetic energy from one point to the other without any permanent displacement of the particles of the medium. Look at that point, very important. He said without any transfer or displacement of the particles of the medium. Now, when we talk about the medium, we are talking about whether it is liquid like water wave, or whether it is through the air like the electromagnetic wave, or whether it is through the strings like the transverse wave of the string, which is the sound wave. So these are different kinds of media through which wave can be propagated. So I don't want this to be a very big thing as you are listening to me. What I want you to understand about wave is that it carries energy, it transfers energy. It is a transferring process or effect whereby the particles, like let's look at these. Let us look at this screen and what is happening on the screen as something that could paint the picture of what the wave is all about. As this is dangling, going up and down, the particle, let's look at this red particle as I'm using my mouse to follow it. You can see it didn't move from where it was to another place. However, look at this wavelength, which is drawn here. It's moving, it's transferring, it's going from one point to the other. However, the particles of the individual medium remains where they are. So when you see a wave, maybe the water wave, something that's moving from one point to the other, it doesn't mean that the molecules or the particles of that medium is moving away. Rather, they are transferring energy from one particle to the other, and as they are moving from one point to the other, and whatever is placed on that media is moved, is carried away. So that is why we call it energy transfer or a disturbance, because something causes it. A wave is produced by a disturbance, a vibration of particle, and that is what causes a wave. Now, I want you to know that before I don't want to say more of the things I have in the lesson, but I want us to take it one after the other. If you look at the screen, you see this kind of wave, which is called a longitudinal wave, and you have another kind of wave, which is transverse waves. But however, look at this again. This one now is a transverse wave. Why this? Look at this one that looks like a kind of slicky thing or a kind of spring. Is called longitudinal wave. This characterizes two types of waves. Now, there is something we call compression and refraction, node and antinode of a wave. Now, let's talk about compression. If you look at this, what do you notice? What you notice is that this point called a point of compression is a point where the waveform is clustered. But before I continue, I want you to know that all these diagrams you are seeing does not mean this is not how the wave behaves when you see it in real life. Like when you see this. In a real life, you don't see this. But this is what scientists have come up with to paint the picture for you to see that, yes, this is how wave behaves. And this is the properties that they have. So look, the diagram also you are seeing here does not mean as I am talking, you are hearing me. It is the sound wave, which is a type of wave called longitudinal wave. It doesn't mean you have to see the sound as it is moving in this spring-like form. However, there is a point called compressional point where they are more clustered, and there is a point called refraction where they are more spaced apart. And that is what we mean by compression and refraction. Where they are more clustered is called compression, and where they are separated far away from each other, that is those imaginary lines in a longitudinal wave is called refraction. Now, when we talk about node and antinode, this is caused by a standing wave. We will talk about what standing wave is. However, when you have a wave, two different kinds of wave, the one which is represented with this red line and the one represented with this blue line, these are two kinds of wave moving opposite to each other, and then they superimpose. And when they combine, they form this kind of thing, whereby the rest position is called the node, while this far more position, which is called the amplitude, far away from the rest position, is called the antinode. Now, we want to talk about waveform. Look at the diagram of a waveform. When we talk about waveform, it is like this. Now, this one is for parallel kind of wave, and this is a circular kind of wave. All these kinds of wave depends on the source which is producing the wave. If a circular form, maybe you use a stone and drop it inside a pool of water or inside a bucket of water, because the object you are using to throw inside the water is circular in nature, it's going to produce a kind of wave which is also going to make a ripple effect in a circular form. If you now use a plank to throw inside a water body or on a water body, is going to also form a kind of parallel ripple effect. So the source of the wave produced, especially in water or other sources of wave, depends on the kind of wave that you are going to see. Now, these imaginary diagrams show the kind of waveform, what it means. However, what does wavefront mean? According to the definition, it said a wavefront is any imaginary line. Remember, the points are very important. Imaginary means that in a real life, you can't see those diagrams. In real life, it's not there. You can't even see it. All these waves, your eyes do not have the capacity to detect them. So a wavefront is an imaginary line or a section of advancing wave. Look at what I mean by advancing wave. That means it started from this source. This is the first thing that produced the wave. Then they keep on making a kind of advancing, moving from one place to the other and spreading far away. That is what we mean by advancing. Advancing wave in which all the particles in this section are in phase with each other. So all of them in this line, they are in the same phase. All of the particles on this also position, they are also in wave with each other. So whatever you place there or you place it here, we still do the same thing. That is what we mean by a wavefront. So the key point here is that it is an advancing wave from a source such that those particles on those lines are in the same wave phase, in the same phase. Now, let's talk about the key classification of wave. When we talk about classification of wave, we are talking about electromagnetic wave and the mechanical wave. Look at this video clip I showed earlier. Look at this one. This is moving this way, and also this one is moving this way. Now, what is electromagnetic wave? Electromagnetic wave are those waves which do not require any material medium for their propagation. That means they don't need any medium for them to, or channel for them to start moving. For example, there are different kinds of electromagnetic wave, like the radio wave, the microwave, infrared, the light. The light you are seeing is a wave. Initially I said your eyes cannot see some wave. There is only one wave that your eyes has the capacity to see, and that is the light you are seeing now. So this light is also a type of electromagnetic wave, and the gamma ray radiation and other ones. They are called electromagnetic wave because they don't need your permission. They don't need anything for them to move. That is why we call them electromagnets. And however, these kind of waves, they have a speed in the speed of light. That means they have about 300 million meter per second. That is the speed. If you go to some advanced physics, they use C to represent speed. Unlike mechanics, we use V. So we have 3 times 10 raised to power 8 meters per second. What I mean is all these electromagnetic waves, they have this speed. That is 300 million meters per second. And what you are watching on the screen is also a kind of electromagnetic wave, because all electromagnetic waves are transverse wave. And what you are watching on the screen is just what transverse wave does. I'm going to show you the other kind. Now, when we talk about mechanical wave, the sound of my voice you are hearing is a kind of wave called mechanical wave, because mechanical wave is a kind of wave that requires a material medium for it to propagate. Examples of such kinds of wave include sound wave, water wave, and wave of a sound produced by a string like the guitar. These are kinds of wave called mechanical wave, in the sense that there is something that must produce it, and there is some channel they require for them to move. Like, as you are hearing my sound, is because of air. Without air, you can't hear what I'm saying, and that is why we call it mechanical wave. An example of mechanical wave is sound wave. Now, these are 2 broad sections of wave. Now, even though we have classified wave in 2 forms, we have types of wave. The 2 types of wave include transverse wave and longitudinal wave. Look at this, what you're watching on the screen. You see how this is moving? Look at this, how it is moving. Those dots you are seeing there is the picture painted for you to imagine that this is wave, like particles of air. Particles of air moving from one point to the other, trying to move, just like a spring. That is how sound travels. And that is an example of longitudinal wave. This one is an example of longitudinal wave, and this is how it moves. However, these ones that you are seeing here, they are called transverse wave. That is how they move. So let me say it again. Now, when you have things like this is called longitudinal wave. This is how it looks in your book. So this is called longitudinal wave. Then the other one that goes this way, this is called transverse wave. So that is it. Now, what the question should be now, the major question you should be asking is, what is a transverse wave and what is a longitudinal wave? A transverse wave is a wave whose direction of propagation is perpendicular to the source of its production. That means they act in a perpendicular direction to the source producing it. However, longitudinal wave is a kind of wave that moves parallel to the source producing it. These are the two definitions for, these are the definition for longitudinal and transverse. Now let's look at the properties of a wave. Whenever you talk about wave, the statements that should come to your mind or the words that are associated with wave. Number 1 is reflection. Number 2 is refraction. Number 3, diffraction. Number 4, interference. And number 5, polarization. Each time you talk about wave, these terms can be used to define wave because wave do all this. However, all the wave can do all this. Remember the examples of wave I listed. I said sound wave, the one you are hearing, the water wave, what happens in water? You know, when an object is thrown there or whenever there is a disturbance or a ripple tank producing wave in the water. So sound wave, water wave, we have all electromagnetic wave. I also want to include the wave through a string like the guitar, you know, which makes this kind of wave. And we also talked about mechanical and electromagnetic. All electromagnetic wave are transverse wave, all electromagnetic wave. Then, but longitudinal wave is only for sound wave. So all wave can do everything except sound wave, which cannot do polarization. There is no polarization in sound wave. Now look at the first thing, which is called refraction. Refraction. What is refraction? First of all, if you look at what is happening here, this side is bigger. The space between the crest and crest, they are bigger, but they are smaller here. What caused that? If you look at this very well, you will see there is a kind of demarcation between the bigger one and the smaller ones. That demarcation is separating between one medium from the other medium, maybe from water to light or any two media. Now, when a wave is traveling from one medium, before it enters another medium, it deviates from the normal direction it started with. We say that refraction has occurred. Let me show you. If you have this, for example, and then this is the direction, let's assume that this is the boundary. This is the boundary. Let's say this is air and this is water. Now, at this boundary, instead of this wave to continue moving in this direction, because it entered another medium, which is water, it deviates and moves in this direction. We say that refraction has occurred. So refraction is simply mean the changing in direction or the speed of a wave as it passes from one medium to another is refraction. Now, let's talk about the second one, which is called diffraction. Diffraction is defined as the spreading of wave after passing through a narrow opening. It works best when the width of the gap is very narrow, about the same length as the wavelength of the wave. Wider gaps don't cause much diffraction. Let me show you what I mean. Look at what I mean by diffraction. Look at what I mean. So this is opening. As this wave is entering, coming this way, it is passing through this opening. It's spread out. As it is going out, it's spreading more and more. We now say that diffraction of wave has occurred. Now, remember this key point that it works best when the width of the gap is very narrow, about the same wavelength, about the same as the wavelength of the wave. We'll talk about wavelength. Let me show you this. when we are talking about wavelength, we are talking about the distance between the successive crests. Remember we said we have wave 2. There are so many other things we are going to talk about in the second wave. Now, if you have a transverse wave in this direction, whatever is being measured with each other, then it moves like this. This is called crest. The top is called crest, and this is called trough. And this is another crest. So when we talk about wavelength, when I'm talking about wavelength, I mean from this point to another point. And it is represented by this symbol called lambda. This symbol, or this letter called lambda, is what is used to represent wavelength. So when and the wavelength is measured in meters, so it's just about length. So what we are saying here is that for a diffraction to be most effective, that this gap, that is from this point to this point, that distance or the length must be the same as the wavelength of any wave. Then we say that that is an effective diffraction. Now, the next one is called polarization. When we are talking about polarization, we are talking about, okay, let's look at the definition of polarization. Okay, polarization is just a way of organizing wave or light, especially because polarization is exclusively to all electromagnetic waves, or should I say all transverse wave. What it means is that, remember that light is scattered, you know, light is moving in all directions because it is a wave. Now, what happened? When we now use something called Polaroid, this Polaroid may be an example of a glass that refines light, you know, something that refines something. So that Polaroid makes this scattered light in all direction to be organized and come out in a more confined, to move in a more direction, in a more organized form. We say that polarization has occurred. So this you are watching is what polarization does. For example, the sunglasses and some other ones. Let's look at a few examples. On that glasses, you see that what it does is to refine the, you can even look at the sun without you feeling pain. But now, as it stands now, with your naked, with your normal eyes, you can't look at the sun. But with that glass, you can look at it. We also have the ones used by sailors and drivers. This is just to reduce the intensity of light from causing more harm or damage to your eyes. So these are what Polaroid does. Then we also look at them here. So look at this. I say that calculator screen, even your calculator screen is also another example of Polaroid. And then look at this one too, the sunglass, which we've said, or the sunshade. These are all what Polaroid are used for. Then let's talk about this one we call interference. When you look at this, what is happening here, you see that there are two different kinds of wave. The one on the blue, the one with the blue color, and the one with the red color, and the other black one, which after some time grows higher in amplitude. So this is just what we call superimposition of wave. Now, when we talk about interference, we are saying that it's defined as superimposition of two or more waves. It is the effect produced when wave of the same frequency, look at the point, of the same frequency, of the same amplitude, and wavelength are traveling in the same direction in a medium superimposed as they simultaneously pass through a given point. So when they are passing through a given point at the same time, they superimpose. So the superimposition there is simply talking about when the two of them are added, the effect, or like the resultant of the two waves put together. And that is why when they now put like this, you see the black wave, which is showing the superimposed wave. Now, we have different kinds of interference. We have the one we call destructive interference, and we have the one we call constructive interference. Now, looking at this diagram also, you see that this wave, look at the wave, this is the crest, and this is the crest. Yes, let me show you. See, the first wave was just moving like this. And the second wave also is moving the same way. So what it means is that they are in phase with each other. So as they are in phase with each other, we say that interference has occurred because they are starting from the same source according to the definition, and they are moving in the same direction. So when the two of them combine, this plus this, we now have a special wave, the biggest of them, or which is called the resultant, or which is the superimposed wave. And this kind of wave, we can call it constructive interference. However, when the two of them combine so that they open, the two waves open the same time, we now say that they are destructive. And that destructive interference leads to what is called standing wave. Let me show you. Now, when we have two waves, this one is moving this way, and then another one is moving this way. You see? So when they now do like this, they now form a destructive interference, such that this at the maximum amplitude or the maximum point is called the antinode, while this point is called node. Antinode and node. Remember what I showed you at the beginning. Let me show you. Look at this one. Look at what we mean by the node and antinode. Look at them. This is standing wave. So this thing is caused by superimposition or interference of waves. Now, when we talk about reflection of wave, that's the last one we're going to talk about, is the throwing off of wave, like the light, reflection of light, like when you use a light from a mirror and you shift it to another direction. We say that reflection has occurred. And reflection is caused by, is defined as the throwing off of light incident on a reflecting surface. And that is what reflection is talking about. Now remember that all these topics we treated, they are just to tell you that wave has this property, or this is how wave behaves. Each of them is a broad topic in physics. That is why we are going to look at them one after the other. So that is why we are not going as deep. However, thank you for being part of this class. But before we go, let us take a few more questions from JAMB on this topic in an Examguide app. Okay, welcome to Examguide app. I'm using UTME or JAMB. So the first question we have here is that the phenomenon of light bending around an obstacle is reflection cannot be it, because reflection is throwing off of light incident on a reflecting surface. Polarization is refining a light to move in a confined direction. Refraction is the changing the speed of light as it passes from one medium to the other. Diffraction is actually the right option. We are not doing calculation for now. Any line or section taken through an advancing wave in which all the particles in the same phase is called wavelength. No, option A is not correct. When we talk about wavelength, we are talking about the distance between the two successive crests. That is not it. Wave coast, never knew. That's funny name. Trough, no. Wavefront is the right option. For a wave to be advancing from a given source, we'll call it a wavefront. The shallowness of a swimming pool is due to what kind of wave, what kind of property of wave. When we talk about the shallowness, have you ever seen something inside a bucket or inside a pool? It looks upper as if the object is coming closer to you than it really is. That is, the apparent depth is up and more than the real depth. That is only caused by refraction, because refraction is the shallowness of an object inside another medium. So diffraction is not diffraction, I mean refraction is the right option, the shallowness of a swimming pool. Okay, let's do this. Now, the above figure shows the motion of a progressive wave. We've not talked about progressive wave. That would be in lesson 2. No. The characteristics of a vibration that determine its intensity is the intensity of a wave. I will go for the overtone. The frequency determines the intensity of a wave. Which of the following wave cannot be polarized? Of course, it should be sound wave. Sound wave cannot be polarized. Every other wave can be polarized here except sound wave. A transverse wave can be distinguished from longitudinal wave using the characteristics of what differentiates transverse wave from longitudinal wave, and that is polarization. It cannot be diffraction, they all do. It cannot be reflection, so polarization is the major thing. Lastly, a transverse wave and a longitudinal wave traveling in the same direction in a medium differ essentially in the what differentiates between, the only question they are asking us here, what is the difference between transverse wave and longitudinal wave? What's the difference? Amplitude, no. Direction of vibration of particle of the medium, yes, because the directions, they are not the same, because transverse wave is going to be moving perpendicular to the source of disturbance, while longitudinal wave is going to be moving parallel to the source of disturbance, and that is the option. That is for option B. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.